Hey, welcome to Key Skill 1. In Key Skill 1, we're going to be looking at how you can find the complex roots of a quadratic equation. We're going to need some pre-existing knowledge here. I have a whole series on quadratic equations, real, repeated, or no real roots. So to refresh, we can basically put all solutions of quadratic equations into three camps. We can have a situation where the equation has two roots, in which the discriminant b squared minus 4ac would be bigger than 0. Now, we can refer to any quadratic equation as ax squared bx plus c equals to 0. So if we rewrite our quadratic equation, we can see that it would have an a, b, and c. This situation, we would have one root, or a repeated root here. So this one's two roots, one root, or a repeated root. And here the discriminant should be equal to 0. And here we have a third situation where we've previously said it has no roots, okay? And here the discriminant would be negative. So we're using the discriminant here as a diagnostic tool. We're going to take our quadratic equation and then we're going to determine how many roots it has using the discriminant. So in our example, we've been told to verify the equation has imaginary roots. Now we're going to extend this scenario here. Instead of saying no real roots, we're going to be able to say it has imaginary roots, okay? So let's have a look at our equation. And we're going to identify a, b, and c. So a here would be 1. You can think of this as 1x squared. B would be 2, and C would be 5. So if we calculate the discriminant, often use the triangle symbol, as b squared minus 4ac, it would be 2 squared minus 4 times 1 times 5. So the discriminant would be 4 times 1 times 5 minus 20, or minus 16. This is in fact a negative number, so we can determine that this would have no real roots. That would mean it does not intersect the x-axis. And we can use our skills that we learned in the previous series on quadratic equations to draw a quick graph. If you imagine that this is x squared plus 2x plus 5, we already know that it's not going to intersect the x-axis. We would normally make y equals to 0 and we would find the solutions of this quadratic equation, but we already know from here, by the fact that the discriminant is less than 0, it was a negative number, that it does not intersect the x-axis. So we're in this situation here. But there's two kind of key points we can find. We can find the y-intercept and we can find the minimum point. So the y-intercept, we're going to make x equal to 0. So that means it goes through the y-axis at 5, and we can complete the square. Again, I have a whole series on quadratic equations that does include completing the square. So I'm going to go through this pretty quickly. So we can see that the max point here, if I look at my completed square form, to change the sign here, my max point would be minus 1, 4. So my rough sketch would look like this. My graph will go through at 0, 4, and at minus 1, 4, it would have its minimum point. So that is what that graph is going to look like, roughly. A rough sketch. And even in your rough sketch, you would kind of label the key points. That's one thing my students often forget. Okay, so we verified that there are no real solutions, and we can visualize that with our rough sketch. So the next question is, how can we find the complex solutions? So we're going to find the solutions in terms of I. So we're going to use, either you can use your completed square form or you can use the quadratic equation. So let's do both of those. We'll start with the completed square form as we already have our completed square. So here, method 1, and I'll write that down so you know there are two methods. Method 1, completed square. So I'm going to make this equal to 0. I've got x plus 1 squared plus 4. I'm going to take the 4 to the other side. I'm going to square root both sides. Now, when I square root this side, it will cancel out with the squared. Now, here I use my knowledge from the previous series that the square root of minus 4 can be rewritten as minus 1 times 4. We can separate that root into minus 1 times square root 4. And that would be I times square root 4 is 2. So that would be 2i equals x plus 1. We can move the 1 to the other side, minus 1. Now, don't forget that when you take the square root here, you can have a plus minus. Plus minus the square root of 2i is equal to x. So that's the method using the completed square form. We can do method 2 over here, which is where we use the quadratic formula. Okay, so I'm going to write down my ABC. A is equal to 1 or 1x squared, B is equal to 2, C is equal to 5. Then I'm going to use my quadratic formula and say x must equal to minus b, minus 2, plus minus the square root of b squared, 2 squared minus 4 times a times c, divided by 2a, or 2 times 1. Okay, let's work out that square root. 2 squared is 4. 4 minus 4 times 1 times 5 minus 20. 2 times 1 is 2. And we're going to get the same answer, you can see, because we're going to get, this is going to become minus 16. Now the square root of minus 16, just like we did here, we can rewrite that as minus 1 times 16 divided by 2. And minus 1 is I, and the square root of 16 is 4, so that would be I times 4, or 4i. The last thing we need to do is divide these both by 2, so that minus 2 divided by 2 would be minus 1. Again, we have plus minus, and 4i divided by 2 would be 2i. Now, it's really important to notice that the roots will always occur in what's called a conjugate pair, which means that the conjugate of minus 1 plus 2i is, that's the first root, so the second root would be exactly the same but a sign change on the imaginary part, and that's really useful in a lot of IB and A-level problems. Okay, so I hope you enjoyed that, and I will see you in the next video where we're going to be going backwards, which is I'm going to give you the roots and you're going to give me the quadratic equation, or the cubic equation actually. See you later guys, bye.